All right, so this video is 5.2b. It is solving systems by substitution, part 2. So you should have had the gist of a substitution problem. And what's happening is, in a way, we're just taking some variable out and replacing it with a bunch of algebraic stuff, I guess you could say, for lack of a better term. So make sure you put the date here that you're taking the notes. And your answer will always be a point, an x and a y. So for example, your answer could be 1, 2, or your answer could be 5, -7. These are the types of things. And really just tying it back into what we were doing in the last section, is that answer is the point of intersection. So this point of intersection, for example, is your answer. And your answer also will be able to plug back into your original equations and be true, be accurate. So right now, just so we have the gist of the last video, I'd like you to, if you're comfortable with it, pause the video and try number 1. See if you can figure out the substitution on that. So pause the video, give that a try. If you're watching the video and you haven't paused, you're still kind of a little unsure about this, what you're trying to do is, right, you have this right here, which is going to be something that equals x. And then you're going to add 2y to that. Whoops. You can do the work while you're listening here. It's fine. You're going to add 2y, that's going to equal 21. So this is kind of this equation right here. Then, what you're going to do is, you're going to take what equals x, which that's 2y minus 3. So pause the video and try to solve that equation, get y, and then try to solve again to get x. Both answers you need to have. All right, so hopefully you get an answer. I will write the answer here. I believe the answer was here, this. And that's our x value, that's our y value. So now we want to check that answer. Here's how we do it. We really have to check both equations. So this first equation I'm bringing over here into the checkbox. And that's x equals 2y minus 3. I'm going a little slow here. But we're going to put the 9 there and the 6 there. And we're going to see if this is equal. So this is how we check. I don't think I've emphasized checking a lot, but this is something we want to do. 12 minus 3, so 9 equals 9. So that's good. However, with these types of equations, you should check both. So this guy's going to come over as well. So we'll have x plus 2y, so we need to do it twice, equals 21. And then we'll put in the x and the y. X was 9. The y was 6. So we have 9 plus 2 times 6 equals 21. So 9 plus 12 equals 21. That's 21 equal to 21, and that's also correct. So you check both equations. The key here was really we just solved this equation, right? We just solved this equation, got an answer for y, which was 6. And then we plugged that back into either the blue equation that I circled or the blue equation I boxed or the red equation that I circled. So let's move on to the next problem. So this isn't too tricky. You can either get x or y alone in these equations. I want to emphasize that because people often think that they have to get y alone, like y equals mx plus b, or they have to get x alone. They can't do whatever one they want, but it's your choice. You can either get x alone and then substitute, or you can get y alone and then substitute. So for the sake of that, let's just look at this problem here. And let's get y alone by simply adding 4 to both sides. So if we had added 4 to both sides, we get this. And then we take this, which is something that equals y, and we put it right there. So this right here, this negative 3x plus 4, is going to go where y was. And everything else from this equation right here, I'll put a blue star here, I guess. That's going to still be there, x plus 5. So x plus 5y. Now y is now written in red, right? So you can kind of see I took this red arrow, it's squiggled all the way down there, and I replaced with that, equals 6. The reason I put parentheses is because it's 5 times y, And y happens to be two things. Because y is two things, you have to multiply that 5 by both of those things. Okay, we'll call them things for the sake of this video. So now I guess I'll use red to show that these are happening like this. This is negative 15x, this is 20, right? This is the gist of what's happening here. The 6 stays, the x stays. I guess we now have, if I just use black here, negative 14x. If I subtract 20, I got equals negative 14. Whoops, shouldn't have an x there. And then we'll just have x equals, I think this will give us x equals 1. Once we have x equals 1, we're not quite done. What we need to do is take an equation. I strongly recommend taking the equation that you first worked out, y equals negative 3x plus 4 in this situation, and plugging in the 1 there. So this is replaced with 1. When you do it that way, it's already solved for y, so you can really get to the answer pretty quick, and I think y ends up being 1 as well. So the answer is 1, 1. We check by plugging that green y equals 1 into both equations, that black x equals 1 into both equations, and seeing if it equals. So some people really like to have steps. So if you need steps, this example gives you all of those steps. So if we go through as much of this as we can before we run out of time here, the first thing is to solve either equation for x or y. Now if you look at this example, this third example, it doesn't matter which one you choose, because both of them can be solved pretty easily, yeah? So Eileen, a lot of people just say, can I solve the top? They just look at the top and they say, if I can solve the top, that's what I'll do. So I go to the top and I say, okay, step 1 in red. Now we subtract 2y from both sides, that's what I'm doing here. I subtracted 2y from both sides to cancel it out, and I now have that. So that's step 1, it's done. Now you didn't need to do step 1 on that equation. You could have also, or you could have done this, y equals, you could have added 3. So you could have also done that. But we're going to erase that so I don't confuse anybody. But you could have solved the bottom if you had wanted to. You don't need to. Now that we've solved, we substitute in using the equation. So when I say substitute in, it's to the other equation that you didn't use yet. If you sub into the equation that you already solved, you'll just get something weird like that equals itself, and it's not going to work. So you'll get I and S, I guess, every time. So y minus 3 equals 4 minus x. X is that red thing up top. So that's going to be negative 2y plus 1. And you're really just solving this equation, the step 2 equation. So you're just doing the algebra out to kind of crank out a solution. I like to say you're just kind of like back to chapter 1 where we just solved a bunch of equations, in a sense. This is a negative 1 that you distribute. Don't miss that, okay? This is a negative 1 that you distribute. Sometimes people miss that. So we got y minus 3 equals 4. Plus 2y minus 1. We've got, I guess, we have, let's say I was to, this is 3 plus 2y. This is y minus 3. We got to get y alone. So I'm going to subtract 2y on both sides. If I do that, I have negative 1y equal, minus 3 equals 3. My bad, minus 3 equals 3. Negative 1y equals, add 3 to both sides, 6. So y equals negative 6. That was the biggest step. There's a lot of work involved in that step. And a lot of people stop here and they're just done, but they're not supposed to be done. Because you're supposed to take that answer that I just circled in black and put it back into the other equation, or either equation actually. So either equation you can put that into. I like to put it into the red one. See this x equals negative 2y plus 11? I like to do x equals negative 2y plus 11, and then x equals negative 2, and then I put this, y equals negative 6 times negative 6. So I got 12 plus 11, I think. So x is going to equal 23. A bizarre number, but it is the correct answer. And that makes our answer 23 comma negative 6. We know that's right because we can plug it back in. or we would know it's right if we plugged it back in. That's kind of where we're at. So if you need to pause and just copy this down, I just want to flip ahead for a second and just kind of show this example is kind of going through it really clearly right here. So this example, and I'm sorry I skipped ahead a little bit, trying to keep this video on the shorter side, running a little low on time here. This shows all the steps. So this example, if you want to kind of just scroll through it and kind of copy as you go, it's on your next page, I think. No? Oh, okay. Scratch that. So forget what I said. I think now all you need to do is this now you try. And you can challenge yourself with the tougher example if you like, but I'd like you to definitely do this now you try, because this video is very much on the shorter side. This was just a kind of an example that kind of scrolls through and shows you how you could do a problem. But this is what I want you to do, and if you're feeling challenged, try this one. I will see you in the next video. Peace.